All right, lesson 3.3 is about parallel lines and the triangle angle sum theorem. Our objectives are to classify triangles and find the measures of their angles, and then use exterior angles of triangles. So, first, vocabulary and key concepts. We've got a new theorem. Theorem 3.7, the triangle angle sum theorem, says the sum of the measures of the angles of a triangle is 180 degrees. Doesn't matter what triangle you have, it's always going to add up to 180 degrees. Then we have theorem 3.8, the triangle exterior angle theorem, which says the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So like if we're looking at the exterior angle 1 here, 2 and 3 are remote. I just think about the ones on the opposite sides of the triangle from the angle we're looking at. Okay, then we're going to look at the different types of triangles. First, we've got an acute triangle. An acute triangle has all acute angles. All of them have to be smaller than 90. Then we have a right triangle. A right triangle has one right angle. And then we have an obtuse triangle, which has one obtuse angle. And then we have an equiangular triangle. An equiangular sounds like exactly what it means. Equal angles. So this triangle has all congruent angles. All the angles are exactly the same. So this is classifying triangles by angles. So we've got 4 choices for that. Then you can also classify them by side lengths. Okay, so here we have an equilateral triangle. Okay, before it was equiangular, meaning equal angles. This one's equilateral, meaning equal sides. So all sides are congruent. Then we have one over here that's an isosceles triangle. And that means that it has 2 sides congruent. So equilateral has 3 sides congruent. Isosceles has 2. Scalene, the scalene triangle has no sides congruent. Each one is its own length. Okay, so you can classify a triangle by angles and by sides. Make sure you remember the difference because it will ask you sometimes to classify it by both. So you need to be able to pick out which of the 4 types of angles it is and which of the 3 types of sides it is. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. So like here, angle 1 is an exterior angle. It's on the outside of the triangle. It's formed by this side and this extension. Remote interior angles are the two non-adjacent interior angles. And I just like to remember they're opposite corners of the exterior angle. So like here, angle 1's the exterior angle. On the opposite side of the triangle, we've got 3 and 2. So those are remote interior angles. All right, let's take a look at some examples here. Example 1, applying the triangle angle sum theorem. It says find the measure of angle Z. So we know that all three angles add up to 180. So 48 plus 67 plus whatever Z is has to add up to 180 by the triangle angle sum theorem. If we add 48 and 67, we get 115. So then if we subtract 115 over from the 180, we end up with 65. So we know that angle Z has to be 65 degrees. Okay, number 2 says using algebra, in triangle ABC, angle ACB right here, is a right angle. CD is perpendicular to AB. So this line in the middle here, perpendicular to this line, it forms a 90-degree angle. Find the values of A, B, and C. So the measure of angle ACB is 90 degrees. We already know that. They told us up there. Because it's the definition of a right angle. Right? Here they told us, hey, this is a right angle. We know right angles are 90 degrees. So C plus 70, because we're looking at this piece over here plus this piece has to make this whole angle, equals 90 by the angle addition postulate. Remember that postulate just told us if we know the measure of two angles and they are next to each other, we can add them up and get the third angle. Okay, so then if we subtract 70 from both sides, we know C is 20. Okay, one thing done. We're trying to find A, B, and C. So then we're going to find A using ADC. So if we look up here, A, D, C. We're looking at this little triangle right there. And we know the measure of angle A plus the measure of angle ADC plus C has to equal 180 by the triangle angle sum theorem. Okay, we know the measure of angle ADC. Well, look, if this is 90 on the other side, they make this straight line, then this also has to be 90 by the definition of a right angle. So then, we know ADC is 90, we know angle C is 20, we know they have to add up to 180. So we just substituted in 90 and 20. 90 and 20 is 110. Still has to equal 180 degrees. If we subtract 110 degrees from both sides, we get A is 70. Right? So there's two things that we know. Now, all we have left to do is find B. So now we're looking at triangle CDB, sorry. CDB. That triangle up there. Okay, so we know A plus CDB plus B equals 180, again by the triangle angle sum theorem. So this theorem gets a lot done. Okay, so angle CDB is 90 degrees. CDB right here. 90 degrees by the definition of a right angle because it's already marked, they told us that. We know A is 70, we know CDB is 90 degrees, we know it all has to add up to 180. So all we did was substitute 70 for angle CDB. If we add these together, 90 plus 70 is 160, and they still have to add up to 180. If we subtract 160 from both sides, we get B is 20 degrees. And now we have found all three angles that we needed using the triangles from the picture. Awesome. So then there are a couple check for understanding problems to do here. First one says triangle MNP is a right triangle. Measure of angle M is a right angle. And N is a 58 degrees. Find angle P. Remember the triangle angle sum theorem. You should be able to find P pretty easily. Then you're going to explain why this statement must be true. If a triangle is a right angle, then its acute angles are complementary. Again, remember the triangle angle sum theorem. If one of the angles is a right angle, how do we know that its acute angles are complementary? Okay, let's look at another example. Applying the triangle exterior angle theorem. Explain what happens to the angle formed by the back of a chair and an armrest as you make the lounge chair recline more. The exterior angle and the angle formed by the back of the chair and the armrest are supplementary. If we look at the angle formed by the chair and the armrest and the back of the chair and the armrest, it has to make a straight line, right? Which together form a straight line. As one measure increases, so like here, they're lounging the chair, they're making this angle get bigger. As one measure increases, so here they were equal, now this one's bigger, so the other measure has to decrease. The angle formed by the back of the chair and the armrest increase. So this angle at the top here that we were looking at, as that one increases, we make the lounge chair recline more. You make the lounge chair recline more. Okay, you've got a couple more check for understanding problems to do, and then you will be done. So the first one says, describe how you could use triangle CAB instead of CDB to find the value of B in example 2. So jump back up to example 2, look at that picture. Then here we're going to find the measure of angle 3. It's that exterior angle there. Then it says give the converse of the statement and check for understanding 1B. So that problem up here, you're going to write the converse of this statement. Converse means to switch the hypothesis and conclusion. Okay. Then draw and mark the triangle to fit each description. If no triangle can be drawn, write not possible and explain why. So we've got an acute scalene. Acute means all the angles are acute. Scalene means no sides are the same. Isosceles right. Isosceles means two sides are the same. Right means you gotta have one right angle. And obtuse equiangular. Obtuse means you have to have one obtuse angle. Equiangular means all the angles are equal. Okay, so go ahead, try those out. Make sure you're checking in with me. If you have questions, let me know.